Hello everyone. Welcome to the second lecture session for design of steel structure at the platform of AKTU Digital Education. Myself Abhay Kumar. Today we will cover the structural steel part for the course under following. First, we will look at the advantages of steel as structural material. Then we will focus on the disadvantages of steel as structural material. Then we will try to understand about the structural steel, what is the structural steel. Then we will look at the types of structural steel, what are the different kind of uh, structural steels are available in the market which are being used for the construction of steel structures. Also, in the next part we will look at the tensile test for the steel. We will focus how tensile test is performed. Then we will look at the stress strain curve which we found from the tensile test of the mild steel. Okay. And in the last part we will look at the Charpy V-notch test. Okay. So, as a structural material, what are the advantages of steel? Okay. So, the first picture which comes to our mind that steel is really a strong material. It gives us very high strength in tension as well as in compression both. If we compare the yield strength or the strength of the material uh, steel and concrete, we will find that we see that steel has yield strength. Even let us talk about the mild steel only. Mild steel has around 250 megapascal of yield strength, whereas if we take the grade of M30 concrete, it has the strength, compressive strength mainly of around 30 megapascal MPa. Okay. So, there is a huge difference in the strength of concrete and steel. Steel is way more stronger than concrete. Also, if we compare that steel has good tensile strength as well as compression strength, whereas concrete has only compressive strength, or we can say that concrete performs way better in compression only. Okay. It does not perform good in tension. Okay. The second property or the second advantage of using steel is that it has high ductility. Sorry. The second advantage of using steel that it has high ductility. Okay. We always want that if sudden load is applied on the structure, or let us say there is an earthquake, okay, then we would never want that sudden collapse or sudden failure occurs to the building. We would always want that building before collapsing gives us sufficient warning and sufficient time so that lives can be saved. So, it is really advantageous to use steel since it has very high ductility comparative to concrete. Then third property is the uniformity. Uniformity sense that when steel is manufactured in plants, in processing plant, sorry, in manufacturing plants. So, they are manufactured in very controlled environment. All the processes are very well monitored and controlled. So, the output material, the material which comes out has way more uniformity than if we compare than concrete. Okay. So, we may found that the end product or the material which is coming out after the manufacturing, it is way more uniform if we compare it to the concrete. Okay. Then third advantage or the next advantage of using steel is that it has more fracture toughness. Okay. How it helps or how it gives us advantage? It gives advantage to the steel that while erection of building or while the construction of the building, it can be easily bent, it can be easily hammered, okay, so that without no any visible cracks we can erect our building, we can construct our building. Okay. Versatility, we can manufacture various kind of hot rolled structures, we can build different shapes of buildings by using steel as construction material. It provides us versatility. Also prefabrication, we can prefabricate our steel members and we can just go on the site and install that. Okay. So, it saves us time. Through this, it way more advantageous than concrete as structural material. Permanence, if we maintain our, if we provide proper maintenance to our steel structures, we may find that it has way more life than any other construction materials building or structure. If we compare, for example, Eiffel Tower was constructed around in 1887, whereas Howrah Bridge, famous Howrah Bridge was started, its construction was started in 1935. So, if we look at these two things, it is these two famous steel structures, these steel structures are standing without any degradation, without any loss in their appearance or and strength also, okay, because they are, their maintenance were conducted in a good manner. Okay. So, the permanence of steel structures is also high. Addition to the existing structure, if we have constructed, already constructed a structure, let us say we have constructed a bridge, a flyover we have constructed by using some steel member, we can easily add another lane, although we have to take care of the by making connection to the existing structure, but we can easily construct the extended part of the structure. Another example, we can also add a new bay to the existing frame, okay, whereas it is not easy to add the new lane or the new bay of the in the existing structure of any concrete structure. Okay. So, in that sense, steel is very advantageous to extend the existing structure. Least disturbance to the community, if we compare its construction to the construction of steel structure to the construction of concrete structure, we will find that it disturbs the community at a very less level than the construction of any concrete structure. Okay. How? Because steels are, most of the time steels are prefabricated, and these prefabricated steel members are instantaneously installed at the site, whereas in the construction of concrete structure or concrete based structure, we prepare the mix at the site, then we place it there and wait for some time, or we provide some curing time to that. This creates a lot of disturbance in the surrounding area. Okay. Also, steel is environment friendly. If the building life is completed, let us say, after the life of the building or the member which are used or after the corrosion, we have to dispose that member or the particular part of the structure. So, steel has some scrap value, first thing, and second thing is that it is easily to dispose of this scrap material in case of steel, whereas it is not environment friendly to dispose of the concrete material. Okay. So, in that case, in that sense, steel is way more advantageous. Though steel has so many advantages to use as an construction material, but steel has some disadvantages also. Okay. Steel is very much susceptible to corrosion, and through this, to avoid this corrosion, we have to provide time to time maintenance or time to time painting of the steel structure. This will definitely add to the cost. Okay. Also, we know that steel, mainly if we talk about the steel as material, it loses its strength at higher temperature. Okay. So, it is and another point is that steel is a good conductor of heat. Steel is a very good conductor of heat. So, if there is a fire outbreak in one part of the structure, so heat will be easily transmitted to the other part, and the other part of the structure will also lose its strength at higher temperature. Okay. And the third is the susceptibility to buckling. What does it mean? As we know, the steel is way more stronger, and the weight to strength ratio of steel is very good. So, we need to use very less material in order to get the more strength. So, the shape of the material or the shape of the member is very much lesser to carry the higher load. In such cases where the load is very much high and the shape is not that much good, so in that case the member may subjected to buckling. Okay. So, to avoid that buckling, we have to provide the additional size of the member, or we need to add some other buckling avoided to other members, so that we can avoid the buckling. Okay. So, this will add some cost also. Okay. So, these are the advantages of steel as construction material, disadvantages of steel as construction material. Now, let us understand the structural steel. So, structural steel is that steel as per IS code which has certain properties, like physical properties. If we focus on it has unit mass of around 7,850 kilogram per meter cube. Okay. The modulus of elasticity of structural steel is around 2 into 10 to the power 5 megapascal. Poisson's ratio is around 0.3. Modulus of rigidity is 0.769 into 10 to the power 5 Newton per mm square or megapascal. The coefficient of thermal expansion is around 12 into 10 to the power minus 6 per degree centigrade. These all data were taken from clause 2.2.41 from IS 800 2007. Some standard mechanical properties for structural steel are defined as yield stress, tensile stress or ultimate stress, maximum percent elongation and notch toughness. Yield stress is that after which the material is yielded. It is that stress value after which the material yields. Ultimate tensile stress, it is that resistance or it is that stress value that member can, that after this stress value member will fail. The maximum percent elongation, it is the maximum elongation that can be applied to that member or that steel. Notch toughness, it indicates the measured absorbed energy before failure. It indicates the toughness or the energy that member can absorb before failure. You can see that there are values given, but there are no values or no fixed numerics are being associated to these mechanical properties, because these will vary with different grade. Okay. One kind of grade of concrete steel will have different yield stress, and other grade of other grade of steel will have different value of yield stress, ultimate stress, will have different percentage elongation and different notch toughness. Okay. So, now let us look at the chemical composition of structural steel. Quality of steel, there are some common steels are mentioned in this table. Okay. These are designated as Fe 410 as Fe stands for iron, 410 is indicating the tensile strength in Newton per mm square. Similarly, Fe 300 indicates that its tensile strength is around 310 Newton per mm square. 410 O stands for ordinary. Okay. Similarly, 410. Okay. So, now let us focus on the carbon percentage, sulfur percentage, phosphorus, manganese and silicon. Okay. So, we know that we have read about how carbon affect in our previous courses, that by increasing the carbon percentage, the strength of the material or mainly the steel increases, not the all the material, steel only. Steel strength increases if we goes on increasing the carbon percentage. Okay. But it is not it is added up to 2%. After 2%, the carbon percentage converts the steel into cast iron. Okay. We will look at this in the next slide. Also, by increasing the carbon percentage, the brittleness in the steel member also increases. Okay. Sulfur. Sulfur is considered as impurity. Okay. Similarly, phosphorus, manganese and silicon. Silicon helps in the dissolve, it helps to dissolve the steel. Okay. So, these are the different chemicals which have different effect on the different properties of the steel. By changing their percentage, we can provide some new properties, or we can enhance some properties in the steel member, or we can manufacture steel of our requirement. For example, let us say we require such a steel which need to has more yield strength. So, we will increase some kind of chemical in there to increase the strength. We require more hardness, we will need to increase the particular chemical. Okay. So, through changing these chemical constituents during the manufacturing of the steel, we can increase the properties, we can alter different properties of the steel. Okay. Okay. ST stands for high tensile. Okay. Now, let us look at some of the different type of structural steel which are available in the market. Though limitation of the space, there are so many steels, kind of steels which are available in the market, but some of the most common used structural steels in the market are mentioned here. First is the carbon steel. Carbon steel is that in which the carbon content is up to 2%. Its yield strength is around 230 to 300 MPa. I told in the previous slide about the cast steel. What is cast steel? Cast iron or cast steel is that in which the carbon percentage is more than 2%. We also know that as the carbon percentage increases, the ductility of the steel member decreases or the brittleness increases. Okay. So, cast iron is way more brittle than the carbon steel. High strength carbon steel means it will have more yield strength. So, okay, so it has yield strength of around 480 to 550 megapascal. It is used in generally in transmission line. Okay. Medium and high tensile strength or microalloyed steel. Such steel are manufactured from the chromium, nickel, molybdenum. By merging these kind of alloy into the steel, we create this medium and high strength microalloyed steel. Its strength varies from, its yield strength lies around 450 to 590 megapascal. Similarly, again another kind of steel is this high strength and quenched and tempered steel. Its yield strength lies around 700 to 950 megapascal. Weathering steel, that is corrosion resistant steel, its strength around 480 megapascal. Fire resistant steel, that is thermomechanically treated. Okay. So, these are different kind of steel which are used in the construction industry. Okay. Now, let us talk about the tensile test of the mild steel. How tensile test is performed, or how we perform the tensile test on the steel member in the lab. So, this figure shows the specimen as per the IS 1608. In this specimen, there are two things which is very important. First is the gauge length and second is the cross sectional area. We draw this or we prepare this kind of a specimen so that when we apply the tensile stress to the member, the stress will concentrate in this region. Okay. The gauge length should be adopted for the, if we take this specimen as rectangular, then the gauge length should be around 5.6 times of under root A naught, where A naught is the area, cross sectional area of this. Okay. If we take this circular, then the gauge length should be around 5 times of the diameter. This is the test setup is shown. In this, we fix our test specimen and we apply the tensile loading. Okay. Now, let us look at the stress strain curve for the mild steel which we will obtain from the tensile test. So, the first figure shows the stress strain curve for the mild steel specimen. In this curve, we can see that yield strength can be easily identified. Okay. And also we will notice that there are two curves are plotted in this figure. First is with the true stress strain curve and second one is the engineering stress strain curve. What is true stress and what is the engineering stress? If we focus here, the true stress is calculated with respect to the actual cross sectional area. Okay. As we elongate our member, we will find that the cross sectional area will decrease after some time, because elongation is going on in the member, whereas ultimate tensile stress is calculated as per the original area of the cross section, which was the original cross section before the starting of the test. Okay. Okay. So, in the next figure we can see that the stress strain curve for ordinary, that is mild steel, and high strength steel is plotted in the same graph. We can see that there is no clear yield strength or yield point in this curve for the high strength steel. So, what we do, how we calculate the yield strength for the high strength steel? We use the concept of proof strain and we take a offset at a strain of 0.002 and draw a parallel line to this initial line, and where it cuts we take that value of stress as our yield stress. Okay. So, this is our stress strain curve for the steel. We will focus more on the stress strain curve of mild steel. We will look at the elastic point, proportionality limit, ultimate strain point. Okay. These all points will be covered in the next lecture. Okay. Thank you everyone.